J. Okay? So if you want to get out your blue sheet or anything like that as well, so you can see where it's at, and then any notes you want to put in your notes. So an alternating series, what does it mean to alternate? What was that? What do you mean go back and forth? Positive and negative, and positive and negative. So you're alternating the signs. So this part right here is all the alternating part, right? Whereas this right here is what we're going to now take for my conditions that we're going to do, okay? So we're going to ignore the alternating part, and we're just going to look at that other sequence part without the alternating. So when I have an alternating series, I'm going to check two things. I'm going to check as I take the limit of that a sub n part, okay, does it equal 0? That's the first condition in order to converge. If the limit, as you go to infinity of a sub n, doesn't equal 0, what? Diverges by nth term. Okay? So after you get this limit to equal 0, the next thing you have to show is that it is, what does this mean? You should say that the next term is smaller than the previous term. Always decreasing. Okay? So you want to see if you are decreasing. And you can show it by plugging in that n plus 1, or you could show it by taking the derivative, okay, depending on the situation. All right, so if you have these two things that work, you can say it converges by the alternating series test. No, you cannot put AST on the quiz or test. For all. And I don't know why, sometimes PowerPoint gets funky like this. I can have to X, so you need to tell me a few more times before I hit the X button or it's gone, okay? I don't know why, sometimes it just does that. Alright, so here's our first one. Determine the convergence or divergence of the following series. So I'm going to take this part right here, which is the non-alternating part. So this is what tells me that it's going to be alternating, right? So I'm going to look at this non-alternating part. Okay, is that okay? All right. So what do I do first? Take the limit as n goes to infinity. Huh? Which is 0. All right. Yay! All right. So we got out 0. So it means it doesn't diverge, but I still don't know if it converges. Okay. Well, yeah. Okay. So there was my first step. Second step, I need to always decreasing. So is this an easy derivative to take? Yeah. So let's take the derivative. Okay. So find that derivative. Low d high minus high d low all over low low. Why does low come first? Low is sad. He was so sad because he was on the bottom. And he says, I don't want to be on the bottom. So he jumps out first. And that's why you have low first. Okay. Where am I at? Derivative was what? Negative n squared plus 1 all over n squared plus 1 squared. Can you cancel anything? Nope. Alright, so this is decreasing for n what? Not for all n. For n starting where? What about at 0? Is it decreasing? No. What about at 1? Is it decreasing? So at greater than 1. Okay? Or you could say less than -1, but we don't care about those negatives because we're starting here at the 1. So we just need to say for some n forward, we're good. So even though it didn't work at 1, it's okay. It worked at 2 and everything bigger than 2. Okay? So these two things tell me what? Converges by the alternating series test. Okay, do the next one. Alright, so I can see the alternating part. It was right there, so I want to take the non-alternating part, get the limit. As I go to infinity of n over 2n minus 1, and what do we get out? Oh, which means what? That is 0. So it diverges by, I can't write fast enough, the nth term test.
I don't know.
Were you there on when we did the Mr. Parkhill and we had that song in part of our skit? Is it to the windows, to the floors, nerds dominate the school? I don't know, something. I don't know. I forget how it all went. Who was Mr. Parkhill that year? For us. Was it Scott Shores? Oh, it was one of the fun. Yeah, that was good too. Alright, so that's the alternating series test. Now we're going to have something really, really cool. If the alternating series converges, only if it converges. So you got to first show that it converges. I know, right? Okay. So if it converges. Alright, if it converges, you can get a really good approximation of the sum that it converges to. So far, what are the only things that we have learned what it converges to for a series? For what? For geometric and for telescopic. Anything else do we know what it converges to? No. So this alternating remainder series theorem, it tells us a really good approximation of what it's going to converge to. So what it says is that whole series, what it actually is, so this is the actual summation, minus here our approximate, and let's say you did it with the first 5 terms. So we went and added up the first 5 terms, so that's our approximate summation. When I take the difference with the absolute value, that's your error. That's how far you're off, right? So the actual minus your approximate, that's the error, right? Well, this is the cool part. That error is less than or equal to the next term. So if I did the first 5, this would be less than or equal to the 6th term. That's pretty cool.
That's pretty neat.
Yeah. Okay, so you can get a really good estimate. Now, how could you get an even better estimate? Instead of using 5 terms, use 50 or 100, or right? You can get a really, really good estimate. And you can see how close you are. Alright, so let's put this into action. In AP, you guys, AP loves to use this theorem, okay? Alright, so I'm going to approximate the sum of the following series by its first 6 terms. So should I go add up the first 6 terms? Let's say it first has to be convergent. So you can't do anything unless you know it is convergent. So let's go first find if this is convergent.
Just a wild guess.
alternating part, and that limit gives you what? 0. Do you know how to take the derivative of a factorial? Okay, Betsy. No, okay? That's okay. So everywhere I want to show that the ace of the n plus the next term, and always use parentheses when you go plug it in, is smaller than the previous term. So I'm going to take this guy right here, and everywhere I see an n, I'm going to put in parentheses, n plus 1. And I want to say, is that smaller than the original, or that previous term, which was 1 over n factorial? Well, let's just simplify a little bit so we can see it. This would be what? 1 over, pull it out, n plus 1 times n factorial. Is that smaller than 1 over n factorial? So what do those n factorials do? They basically cancel. So is 1 over n plus 1 smaller than 1? Yes. Okay? So you are decreasing. Alright, so now that we know this converges by the alternating series test, we can go and approximate the whole summation and see how good we've got that approximately. So let's find the first 6 terms. So plug in a 1, negative 1 to the 1 plus 1 ends up being a positive over what? 1 factorial, which is 1. Then I know it's alternating, so it's going to go minus 1 over 2 factorial, which is 2, plus 1 over 3 factorial, so now 2 times 3 is 6, minus 1 over 4 factorial, so 6 times 4 is 24, plus 1 over 5 factorial, so 24 times 5, 1 what? 120. And then minus, running out of room, 1 over 6 factorial, so 120 times 6 is 720. So S sub 6, add all those together, you can use your calculator, see what you get. Alright, so what do I need to find next? Do I know the actual? So I don't know as I go to infinity what that actual is, but I know that that minus 91 over 144, that S sub 6, has to be less than or equal to what? Not S, but the next term, which would be A sub 7. So you guys say R, right? Yeah. Okay. Where did R come from? Oh, the remainder. Yeah. So that's the remainder. We're going to say that the remainder is actually less than or equal to the next term. Okay? So, right. So if we did the 6, then we have to do plus 1. And what is that next term? Go find it. That'd be 1 over 7 factorial, which is 1 over what? 5,040. So our error is pretty small, right? like go find all of that. Let's do some algebra. So S of infinity minus 91 over 144 is less than or equal to 50, 40, 1 over 50, 40, which is also greater than or equal to negative 1 over 50, 40. Remember that from Algebra 1? 2? Yeah, you did this a lot. This is all an and statement. Oh, yeah. I remember less and great or. That's my little trick for that, yes. Okay. Yeah, less and great or. Alright, so let's see, go add 91 over 144 to both of these guys, and let's see what our actual sum, if I go forever and ever and ever, would be between. I actually have it in decimals, sorry. So I've approximated it. You guys can keep it however. But when you see it in decimals, you can really see like how close it is. In fractions, it's kind of easy to see, but not really. As a decimal, you're like, oh my gosh, look. At least 2 decimal accuracy, right?
3.
If you counted 3. Okay? So, was this a pretty good approximation? Yeah, well, depending. If you have a rocket being launched, right? You want that big of an error? Alright. If you're building a bridge, that error could make like the 2 sides not even meet as you're like building it closer and closer. Like, ah. So it's all relative to what you're dealing with. Alright. We're going to go ahead and go to the slides. So you can kind of skip over that little part. Let's look over it if you want. Okay? Now, are you ready for this? Not only can things converge, they can conditionally converge or absolutely converge. Oh, man, right? And I'm going to show you what that means in a second. Okay? So, if the absolute value converges, done. It is absolutely convergent. If the absolute value diverges, but then you go and you look at the original and it converges, then guess what it's going to do? Conditionally converge. Yeah, there's a balloon down.
It did.
Alright. So, what happens if this guy diverges and this guy diverges? Then it diverges. Okay? Alright. So let's go find, and then at the end I'll show you what it means. Let's look at this one. Let's first see if it's going to be conditional or absolutely convergent. Let's go find that. So let's start with the absolute value first and see if it's absolutely convergent, because if it is, we're done. Okay? Remember, the absolute value gets rid of the alternating part, right? So what does this do? Converges by the p-series. So since the absolute value converged, what is it? Absolutely convergent. Do you have to do any more? No.
You don't have to do anything to the other one.
Nope. the other one's going to converge as well. This is absolutely convergent. No factorials. Just, yay! Anyway, one more time on this. Kim? Yes? Yes.
Could it ever be in like absolute values or something?
For department.
What do you mean?
I don't know if there's like absolute values on the bottom or something.
We put in the absolute values. Yeah. Okay. Let's look at this one now. Let's go check out the absolute value. Hey, McKady, what is this the most common test, like, set up for? What test is this the most common? When you see this? No. Try again. Josh. No. Try again. You. Take a guess.
It's harmonic.
The integral test. This is the most common integral test, 1 over n plus 1. Okay? It's the most common one that you're going to use the integral test for. Alright, so for the integral test, what do we have to show? Positive, continuous, and decreasing. Go for it. So it's positive for n greater than 1 or greater than 0. So you could say greater than or equal to 1 or greater than 0. Whatever. Continuous, let's see. N cannot equal -1. So good, we're continuous for n greater than or equal to 1. Okay? Or you could just say greater than 0, whatever. As long as you are from some point forward, you're good. And the third one, what'd you get your derivative to be? -1 over n plus 1 quantity squared, which is always decreasing, right? So you're good. Is that okay? So now we get to take the integral. So the integral from 1 to infinity, or I could say 1 to b, the limit as b goes to infinity, 1 over n plus 1 dn. What do you get out? Try again. No.
I derived it. I didn't hit it.
Infinity. And I'm going to wait while you get the antiderivative now instead of the derivative. So diverges, so this by the integral test, so this is not absolutely, right? Okay. hey, does it converge at all? So now let's go see if it is conditionally convergent. This one was kind of saying, hey, is it absolutely convergent? If you want to kind of like label what we were doing. I don't know if that helps you, okay? So now let's go see if it's conditionally convergent. What test are we going to have to try here? The new test, which is the alternating series test. So let's try the alternating series test. We have to do two things for the alternating series test. Make it in there? No. What do you need? So you got to check two things. Let me go to 0, and is it decreasing? So the limit of the non-alternating part, does it go to 0? Yes. And we already showed it was decreasing, right? If you want to show it on the go for it. Just do a little arrow. Okay, we already, that's exactly what you're doing, that same thing, right? So it is decreasing, so this converges by the alternating series. So we know that now overall, when I kind of talk overall, this is conditionally convergent. Woo! Oh.
Can I have a real world example?
No. I cannot think of one right now. But what your brain is doing right now is developing skills for real world. Think of all of those connections and whatever. All right. Anybody need more time on this? Okay. So you ready to have your minds blown? Okay. This right here, alternating series, we go like this. And I'm telling you, this is equal to the ln of 2. Okay? So if you were to go and like add them up forever or put it in your calculator, it is the ln of 2. Now, I'm going to show you what conditionally convergent means. We're going to rearrange these terms just a little bit. I'm going to take out the first two positives. So I'm going to have 1 plus 1/3 and then minus 1/2. Now what do I want to do? I'm going to go the other way. Sorry. I got to think about it. I'm going to do the first two negatives, so pull out the other negative. Minus 1/4 and then the next positive. That's what I want to do. 1/3. So I'm just rearranging. So I've got that one, I've got that one, I've got that one, I've got that one now, right? Just rearranged. We're going to rearrange a little bit more. Pull out the next two negatives. What would they be? The negatives are going to be the evens, right? So minus 1/6 minus 1/8, and then what am I going to be left with? The next plus 1/5 minus 1/10 minus 1/12 plus 1/7, etc. Right? So all I did was rearrange. Okay. Then I'm going to group those, etc. So I'm going to put these two together, and what's 1 minus 1/2 become? 1/2, and I still just had minus 1/4. Right? What's 1/3 minus 1/6? 1 what? 1/6. And then I still have minus 1/8. What's 1/5 minus 1/10? still had minus 1/12, etc. Right? So now this new pattern, let's see, I'm going to pull out a half from everything. And let's see what's left. Yep. That's a 10. So let's pull out a half from everything. So what am I left with here? 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6, etc. And hey, that's the same as 1/2 times what? ln of 2.
How is it the end?
Because that's what all of this was equal to. Right?
Oh, yeah.
That's the same thing. No! I'm just showing you what you can do now. Okay? So that whole thing is what we just saw, which is equal to the ln of 2. This is what it means to be conditionally convergent. You can converge to different sums. If it was absolutely convergent, you can only converge to one sum. This one is, since this, right, is like the ln now of radical 2, but it was exactly the same thing, right? So it's conditionally convergent.